Okay, now we continue with second subtopic. Okay, so this is a remainder theorem. So what is remainder theorem? Okay, so by the end of the lesson, students should be able to use remainder theorem and factor theorem. Okay, factor theorem will be in 4.3 later on. Okay, what is remainder theorem? When a polynomial px is divided by a linear factor, okay, linear factor, make sure it is a linear factor. Linear meaning that is power 1 here. Then the remainder is PA. Okay, so how we prove this? Okay, so this proving is just for your extra knowledge. So let px be a polynomial of degree n where n is greater than or equals to 2. Then px equals to qx. Okay, this is your dx, yeah? This is coming from the previous subtopic just now. Okay, dx plus rx. Okay, so when you are dividing your px with x equals to 2, x equals to a, okay, x minus a lah, x minus a you solve equals to 0, then you have x equals to a. Okay, when you substitute x equals to a inside here, so it become a qa, a minus a plus rx here, sorry, ra. Okay, this one will become 0, so 0 multiplied with qa, everything will be 0, so you left only r equals to pa. So this one, r equals to pa. So this is the conclusion. Since a minus a equals to 0, then the remainder is r equals to PA. So remember, by remainder theorem, you will have this expression, r equals to PA. So if px is divided by x plus a, then your x, how to find this value? You solve this x plus a equals to 0, then x equals to negative a. And this one, ax minus b equals to 0, then x equals to b over a. Okay, same thing, if you have a linear equation, linear factor ax plus b equals to 0, then x equals to negative b over a. If x minus a equals to 0, then x equals to positive a. Then you substitute a inside the polynomial px. Okay, let's look at the example. Find the remainder when your px is divided by this 3 linear. So what is the value that you need to substitute? So x plus 3 equals to 0, then you substitute x equals to negative 3. So this value you substitute inside x. Okay, then you find what is the value, p negative 3. Second one is p 3, and the third one is p 1 over 3. So what you get, okay, like this, huh? So this is the remainder, this is the remainder, this is also the remainder. If you didn't use this formula, then you have to do long division. Okay, long division, this px, for example, the first one, px divide with x plus 3. Find the quotient, then do up until you get the remainder down here. Okay, so you can choose. If the question is asking you using remainder theorem, then you have to do this formula, just substitute the value. Okay, next, when x4 plus kx cubed plus 5x squared minus 6x minus 8, so this is your px, is divided by x plus 2, remainder is 16, determine the value of k. So by using remainder theorem, you have p negative 2 equals to 16. How you get negative 2? You solve this x plus 2 equals to 0, then x equals to negative 2. Then you substitute a value. Okay, this negative 2 you substitute into the px like this. Negative 2 power 4 plus k, negative 2 cube plus 5, negative 2 square minus 6, negative 2 minus 8 equals to 16. Then this one you can find the value, also this one and this one, then you move to the other side. Then you left only negative 8k equals to negative 4, then k equals to 3. Okay, The third example here, polynomial p x equals to ax4 minus 5x cubed plus bx squared minus 7x plus 1 left a remainder of negative 8 when it is divided by x minus 1. So the first condition given, you have p1 equals to negative 8. Second one is p negative 1 over 2 equals to 11 over 2. Okay, there are two equations. When you substitute the value of x, do you get the first equation and second equation by using second condition? Now you have a linear equation in the term of a and b. Okay, a and b. So these two equations you will solve using elimination method, okay, or solving by simultaneous equation. Up to you, you can choose either one. Okay, then you get b and a value. Okay, this example also same. When x4 plus 4x cubed plus bx squared plus qx plus 5 is divided by x squared minus 1. So this is not a linear factor, this is a quadratic equation. So you cannot simply use the formula just now. So what you need to do, you must use general equation. Px equals to qx multiply with dx plus rx. So what is your px? Is this expression x4 plus 4x cubed plus bx squared plus qx plus 5 equals to, okay, you don't know what is your qx, but you know your divisor is x squared minus 1 plus rx. This is your remainder, 2x plus 3. So your aim is to find p and q. So how to find p and q? You must eliminate this because you don't know what is the expression of qx. How to eliminate qx? This qx must multiply with 0. So how to make x squared minus 1 equals to 0? Then you have to substitute x value. You can substitute x equals to 1 and x equals to negative 1. Okay, when you substitute x equals to 1, 1 squared minus 1, you will end up with 0. So 0 multiply with qx, you will end up with 0. So the whole term will be gone. Then you left only 2x plus 3. The remainder, you will left only the remainder, this one. Then you substitute, then you will have the first equation. Okay. Second, you substitute x equals to negative 1. Right? Negative 1, negative 1. Same thing. When you substitute negative 1 inside here, negative 1 square, you will get 1. 1 minus 1, 0. So 0 multiply with qx, the whole thing will be 0. Then you left only 2 times negative 1, negative 2 plus 3. So second equation. Okay. Using the same method, solving these two by elimination or simultaneous equation. Okay. Then you get your P, then you get your Q. Okay. Next. Okay, settle for the remainder theorem. Next, we look at what is factor theorem. Okay, just now remainder theorem. Remainder theorem give you R equals to PA. Okay. When you divide your px with a linear factor, you substitute a inside here, then you will have a value. In factor theorem, your PA will be equals to 0. It's different. Factor theorem will be giving you 0 value, but remainder theorem will be give you a value. Wait, that is the remainder. Okay. So definition, this is the definition. If the remainder obtained from dividing your polynomial with x minus 1 is 0, then the linear term is called a factor, okay, of the polynomial. If PA equals to 0, then x minus a is a factor of PA. But just now in remainder theorem, PA equals to R, kan? Equals to R, then this is remainder theorem, and X minus A is not a factor of Px. Okay, different. Same thing, this is how we find the A value. You just make it equals to 0, then you get X equals to A. And this one equals to 0, then X you will get negative B over negative B over A. Negative, yeah, because this one is AX plus B equals to 0. Okay. Example, this is a very easy example. Determine whether the following linear function are factors. Factors, you must show that PA must be 0. So in this case, x minus 3 equals to 0, then x equals to 3. So x equals to 3, you substitute into the equation here. Did you get 0? If you get 0, meaning that this linear is the factor. For example, like this. You substitute x equals to 3, then it gets 0. P3 equals to 0, then x minus 3 is a factor of Px. Okay, very easy, kan? Same thing. Second one. And the third one just now is x plus 1. So we substitute the linear that you want to test is x plus 1 equals to 0, then you substitute x equals to negative 1, kan? X equals to negative 1, then we substitute into the Px, you get negative 6. So meaning that x plus 1 is not a factor of Px. Okay. In other words, when you do long division, Px divided by x plus 1, then you will end up a remainder here. Okay. But this one, the one that is a factor, when you do long division, Px 2x plus 1, when you do long division, then you will end up with no remainder, is 0. So we can say that 2x, sorry, this one is minus. 2x minus 1 is a factor. Okay, how about this one? This is the combination given that x minus 2 and x plus 1 are both factor. If both are factor, they ask you to find a and b, constant, coefficient. So from here, we know that P2 equals to 0. P negative 1 equals to 0. So this 2 you substitute inside here, then you will have equation in terms of A and B, like this. You will have this, A and B. And then second one, this one, second condition, P negative 1, you will get the second equation in terms of A and B. So by using elimination method or solving by simultaneous equation, solve equation 1 and equation 2, then you get A and B. Same thing. This one also easy. Okay. Given that x plus 2 is a factor of 2x cubed, find the constant k. Okay, you know that P negative 2 is 0. Then you find k. Okay, now you get, this is your Px. Okay, the first question. Factorize the expression completely. Okay, so from here you get Px equals to 2x cubed plus x squared minus 8x. Okay, so your Px equals to 2x cubed plus x squared minus 8x minus 4. Then you already know that x plus 2 is a factor. Then you can factor out ini. X plus 2 ini. You can factor out x plus 2. You can factor out x plus 2. Okay. After you factor out x plus 2 from this cubic function, you left a quadratic di sini. Okay, kita padam dulu. Okay, jawab mana pointer pen. This is a cubic. Okay, when you factor out power 1, you left a quadratic equation here yang power 2. Quadratic equation. Okay, quadratic equation. Because from the previous subtopic tadi, if product is power 3 and you know one of the polynomial is 1, the other one will be 2. So product of these two will be addition of the highest power. 1 plus 2 you get 3. So we know that here must be a quadratic equation. So how can we find this quadratic equation? We can solve by long division. When you do long division, so definitely there is no remainder should be 0 because this is a factor. Then you get this, kan? Okay, now you have 2x squared minus 3x minus 2 multiplied with x plus 2, remainder 0. So this here you don't have to write plus 0, no need, just leave it like that. Then ini yang quadratic ini, if you can factor out, then you must factorize because the question is factorize completely. Okay, so you must factorize completely, then settle here if you are using long division. If you are not using long division, also can. Since we know just now here, okay, cubic, you already factor out power 1, then we know here is quadratic equation. So what is the general equation for quadratic equation? Ax squared plus bx plus c, kan? So you know this is the equation. Now you expand this two bracket, kembangkan, kemudian kamu buat comparison dengan coefficient ini. Sini coefficient dia 1, ini coefficient dia negatif 8. Katalah yang ini, kan, x multiply dengan ax squared. So you will have ax cube. Okay, so when you do comparison 2x cube dengan ax cube, so we can say that a equals to 2. That's why you have like this. Okay, C. Then same answer, the answer will be the same. Okay, so ini another example. Okay, they ask you to find P and Q. The condition given, x plus 3 is a factor, then we know that P negative 3 equals to 0 and leaves a remainder of 4, then the other one is P1 equals to 4. Okay, two equation, you will end up with the equation in terms of P and Q for both, then solve by simultaneous equation again or elimination. Okay, you can refer in the lecture note later on, yeah. Okay, I think that's all for the second and the third subtopic. Okay, later on I will discuss this in the third video lah. Okay, see you.